So this is TMUA 2016 paper 2, and we're looking at question 16 this time. So this is an interesting question. Whenever you see kind of lines all over the place on a shape like this with some parallel lines, the chances are it's something to do with similar triangles. So the first question you're likely to ask yourself is, where are the similar triangles? So I actually did this originally in a way that I knew there was probably a more effective way to do it, but it was just the first thing that came into my mind and I went with it. So I'm going to show you that first. So what I thought is, often with questions like this where you've got trapezium, it's about chopping the top off a triangle. So I kind of made the triangle go like this. And so I had, if you will, three similar triangles. So I had this one here, this one here. If I call this point O, say. So I've got SRO is one similar triangle. I've got UTO is another one. And then I've got PQO as well. And those three triangles are similar because they all have the angles on all three of them are the same. And we know that because these parallel lines here. So we know that that angle is the same as that one, is the same as that one. And that's the same as that, same as that. And so what I then had to do was introduce this as Y. And I also noted that there were similar triangles PQX. So triangle PQX was similar to triangle SRX. And that is that one and that one. And I've used the fact that we've got opposite sides of opposite angles, if you will. So we've got that angle there and this angle here. But then we've also got alternate angles. So this angle here is alternate to that angle here. Now, because SR is the corresponding side to PQ, I know that the ratio, the scale factor between PXQ and SRX is 4:1. So I can call this, I'm going to call this X. I'm going to call this 4X. Now, I knew at this point that there was probably a better way, but I felt it wasn't going to take me that long to do. So I said, well, if I look at triangle ORS, I can say its perpendicular height is y and its base length is 3. So I've got y over 3. And I can say that's the same as y plus x over ut. Now, bear in mind, ut is the thing I want. And then I've got that's also equal to y plus 5x over 12. And then I can solve this by, first of all, if I consider this equation to have three parts, so maybe part 1, part 2, part 3, I can say y over 3 equals y plus 5x over 12. And I can use this to get y in terms of x. So I end up with 4y equals y plus 5x, which means 3y equals 5x. And therefore, that tells me that y equals 5 over 3x. And I can then substitute this in to either 1 equals 2 or 2 equals 3. And then I'm going to be able to get ut on its own, and you'll see how that works. So I can say, let's go for 1 equals 2. So I can say 5 over 3x all over 3, which I'll simplify in a minute, equals 5 over 3x plus x all over ut. Now, there's a few ways I can simplify this, but I'm going to just consider for the moment multiplying both the left and the right hand side by 1 over x, which will give me 5 over 3 over 3. So 5 over 9 equals 5 over 3 plus 1 over ut. So 5 over 9 times ut equals 5 over 3 plus 3 over 3, 8 over 3. And then from there, I can get that ut equals 9 times 8 over 3 times 5, which is the same as 3 times 8, 24 over 5, which is 4.8. So that's one way of doing it. I was able to do that relatively quickly. Obviously, I've slowed myself down a bit there to try and explain it. But actually, when I then went back, there's definitely a better way of doing it than that. Because of the y and the x and the ut, I've essentially got 3 variables in there. So what I then went back and said, well, we've also got similar triangles PRQ, and that is similar to ignore that bit. That is similar to RTU. So those 2 triangles are similar again because of the alternate angles. So we've got that equals that, that equals that. And so if we still use a similar idea of calling that x, and we know this is 4x, now that's still gained from using the fact that triangle PXQ is similar to SXR. So we're still using triangle SRX and triangle PXQ. I can't see a way of doing it without using those 2 to get this 4x and x. But then I can say from here, I'm just going to rub all this out, I can say, well, xt, so small x over xt equals 5x over pq, which is 12. So that's using the height of rxt divided by the width equals the height of rpq divided by the width. And then obviously Rx is going to simplify down, and we very quickly end up with xt equals 2.4. We can do something very similar then for this triangle is similar to this triangle. In fact, we end up doing exactly the same thing to get that ux is also 2.4, and therefore the total ut is 4.8. Hope that helps. Please send me any questions that you may have.